Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Time to enter the world of civil engineering. Here we will learn about different concepts related to civil engineering. Please subscribe to the channel and press the bell icon for more new updates. In today's video we are going to discuss about building materials, bricks and classification of bricks. Definition: brick is the smallest building unit made up of silica, clay, lime, iron oxide, and magnesia. There are many types of bricks in construction industry which are defined on the basis of different criteria. Bricks are widely used in masonry construction due to its aesthetic value, high compressive strength, fire protection, and provides the required wear resistance. Length of brick equals 2 times width of brick plus thickness of mortar. Height of brick equals width of brick. The size of the bricks are of 190 mm times 90 mm times 90 mm. Popular size of brick used in India. Modular/metric brick, nominal size 10x 20 cm. This size is common in MP and only some other places where machine-made bricks are available. English size 23x 11.5x 7.5 cm or 9x 4.5x 3 nominal size. This is the most popular size available in most parts of India. Bengal size 25x 12.5x 7.5 cm size or 10x 5x 3. This size is popular in West Bengal and some parts adjoining West Bengal and Northeast. A few other sizes are also used in some localized areas. Percentage of constituents of brick, weight basis. There are 6 major ingredients of brick. The general percentage of these ingredients in brick is given below. Serial number. Ingredient. Percentage in brick. 1. Silica, SiO. 2. 50% to 60%. 2. Alumina, Al. 2. O. 3. 20% to 30%. 3. Iron oxide, Fe. 2O. 3. 5% to 6%. 4. Magnesia, MgO. 1%. 5. Lime, CaO. 10%. 6. Alkalis. 7. Very less percent of carbon dioxide, sulfur trioxide, and water. Silica function in brick. It exists in clay either as free or combined. As free sand, it is mechanically mixed with clay. In combine form, it exists in chemical composition with alumina. A good brick material should contain about 50% to 60% of silica. The presence of this constituent prevents cracking, shrinking, and warping of raw bricks. It thus imparts uniform shape to the bricks. The durability of bricks depends on the proper proportion of silica in brick material. The excess of silica destroys the cohesion between particles and the bricks become brittle. Alumina function in brick. It is the chief constituent of every kind of clay. A good brick should contain 20% to 30% of alumina. This constituent imparts plasticity to the clay so that it can be molded. If alumina is present in excess, with inadequate quantity of sand, the raw bricks shrink and warp during drying, burning, and become too hard when burnt. Oxide of iron function in brick. A small quantity of oxide of iron to the extent of about 5 to 6% is desirable in good brick material. It helps as lime to fuse sand. It also imparts red color to the bricks. The excess of oxide of iron makes the bricks dark blue or blackish. If, on the other hand, the quantity of iron oxide is comparatively less, the bricks will be yellowish in color. Magnesia function in brick. A small quantity of magnesia in brick material imparts yellow tint to the bricks and decreases shrinkage. It rarely exceeds 1%. However, excess of magnesia leads to the decay of bricks. Lime. Bricks should contain a little amount of finely powdered lime. It enables silica, of a required portion, to melt at the furnace temperature of 1650 C and binds the particles of brick together, resulting in strong and durable bricks. At about 1100 C, lime acts as a catalyst to elevate the furnace temperature to 1650 C, at which silica fuses. This slightly fused silica works as a strong cementing material. Excess lime in brick clay will cause vitrification of bricks. It causes bricks to melt, as more than the required amount of silica will fuse. The bricks then lose their shape and become disfigured. Alkalis. These are mainly in the form of soda and potash. The alkalis act as a flux in the kiln during burning, and they cause bricks to fuse, twist and warp. As a result, the bricks are melted and they lose their shape. Further, the alkalis remaining in bricks will absorb moisture from the atmosphere, when bricks are used in masonry. Such moisture, when evaporated, leaves behind gray or white deposits on the wall surface. The appearance of the building as a whole is then seriously spoiled. Classification of bricks. Classification of bricks based on quality. First-class bricks. Second-class bricks. Third-class bricks. First-class brick. The size is standard. The color of these bricks is uniform yellow or red. It is well burnt, regular texture, uniform shape. The absorption capacity is less than 10%, crushing strength is 280 kg cm2, mean, where it is 245 kg cm2, minimum. It doesn't have efflorescence. It emits a metallic sound when struck by another similar brick or struck by a hammer. It is hard enough to resist any fingernail expression on the brick surface if one tries to do with a thumbnail. It is free from pebbles, gravels or organic matters. It is generally used in a building of long durability, say 100 years. For building exposes to a corrosive environment. For making coarse aggregates of concrete. Second-class brick. The size is standard, color is uniform yellow or red. It is well burnt, slightly overburnt is acceptable. It has a regular shape, efflorescence is not appreciable. The absorption capacity is more than 10% but less than 15%. Crushing strength is 175 kg cm2, mean, where the minimum is 154 kg cm2. It emits a metallic sound when struck by another similar brick or struck by a hammer. It is hard enough to resist any fingernail expression on the brick surface if one tries to do with a thumbnail. It is used for the construction of one-storied buildings, temporary shed when intended durability is not more than 15 years. Third-class brick. The shape and size are not regular. The color is soft and light red colored. It is underburnt. Slightly overburnt is acceptable. It has extensive efflorescence. The texture is non-uniform. The absorption capacity is more than 15% but less than 20%. The crushing strength is 140 kg cm2, mean, where the minimum crushing strength is 105 kg cm2. It emits a dull or blunt sound when struck by another similar brick or struck by a hammer. It leaves fingernail expression when one tries to do with the thumbnail. Classification of bricks based on building process. On the basis of the building process, bricks are of following kinds. Unburnt bricks, these are half-burnt bricks. The color is yellow. The strength is low. They are used as cirque in lime terracing. They are used as soiling under RCC footing or basement. Such bricks should not be exposed to rainwater. Burnt bricks. Burnt bricks are made by burning them in the kiln. First class, second class, third class bricks are burnt bricks. Overburnt or llama brick. It is often known as the vitrified brick as it is fired at high temperature and for a longer period of time than conventional bricks. As a result, the shape is distorted. The absorption capacity is high. The strength is higher or equivalent to first-class bricks. It is used as lime concrete for the foundation. It is also used as coarse aggregate in the concrete of slab and beam, which will not come in contact with water. Classification of bricks based on manufacturing method. On the basis of manufacturing method, bricks are of the following kinds. Extruded brick. It is created by forcing clay and water into a steel die, with a very regular shape and size, then cutting the resulting column into shorter units with wires before firing. It is used in constructions with limited budgets. It has 3 or 4 holes constituting up to 25% volume of the brick. Molded brick. It is shaped in molds by hand rather being in the machine. Molded bricks between 50 to 65 mm are available instantly. Other size and shapes are available in 6–8 weeks after the order. Dry pressed brick. It is the traditional types of bricks which are made by compressing clay into molds. It has a deep frog in one bedding surface and shallow frog in another. Classification of bricks based on raw materials. On the basis of raw materials, bricks are of the following kinds. Burnt clay brick. It is obtained by pressing the clay in molds and fried and dried in kilns. It is the most used bricks. It requires plastering when used in construction works. Fly ash clay brick. It is manufactured when fly ash and clay are molded in 1000 degrees Celsius. It contains a high volume of calcium oxide in fly ash. That is why usually described as self-cementing. It usually expands when coming into contact with moisture. It is less porous than clay bricks. It proved a smooth surface, so it doesn't need plastering. Concrete brick. It is made of concrete. It is the least used bricks. It has low compression strength and is of low quality. These bricks are used above and below the damp-proof course. These bricks can be used for facades, fences, and internal brickworks because of their sound reductions and heat resistance qualities. It is also called mortar brick. It can be of different colors if the pigment is added during manufacturing. It should not be used below ground. Sand lime brick. Sand, fly ash, and lime are mixed and molded under pressure. During wet mixing, a chemical reaction takes place to bond the mixtures. Then they are placed in the molds. The color is grayish as it offers something of an aesthetic view. It offers a smoother finish and uniform appearance than the clay bricks. As a result, it also doesn't require plastering. It is used as load-bearing members as it is immensely strong. Fire brick. It is also known as refractory bricks. It is manufactured from a specially designed earth. After burning, it can withstand very high temperature without affecting its shape, size, and strength. It is used for the lining of chimney and furnaces where the usual temperature is expected to be very high. Classification of bricks based on using location. On the basis of using location, bricks are of the following kinds. Facing brick. The facade material of any building is known as facing brick. Facings bricks are standard in size, are stronger than other bricks and also have better durability. The color is red or brown shades to provide a more aesthetic look to the building. There are many types of facing bricks which use different techniques and technology. Facing bricks should be weather resistant as they are most generally used on the exterior wall of buildings. Backing brick. These types of brick don't have any special features. They are just used behind the facing bricks to provide support. Classification of bricks based on weather-resisting capability. On the basis of weather-resisting capability, bricks are of following kinds. Severe weather grade. These types of bricks are used in the countries which are covered in snow most of the time of year. These bricks are resistant to any kind of freeze-thaw actions. Moderate weather grade. These types of bricks are used in tropical countries. They can withstand any high temperature. No weather grade. These bricks do not have any weather-resisting capabilities and used on the inside walls. Classification of bricks based on their using. There are many uses of bricks. On the basis of the purpose of their using, bricks are of the following kinds. Common bricks. These bricks are the most common bricks used. They don't have any special features or requirements. They have low resistance, low quality, low compressive strength. They are usually used on the interior walls. Engineering bricks. These bricks are known for many reasons. They have high compressive strength and low absorption capacity. They are very strong and dense. They have good load-bearing capacity, damp-proof, and chemical resistance properties. They have a uniform red color. They are classified as Class A, Class B, Class C. Class A is the strongest but Class B is most used. They are used for mainly civil engineering works like sewers, manholes, groundworks, retaining walls, damp-proof courses, etc. Classification of bricks based on shape. On the basis of shape, bricks are of following kinds. Bullnose brick. These bricks are molded into round angles. They are used for rounded coin. Air bricks. These bricks contain holes to circulate air. They are used on suspended floors and cavity walls. Channel bricks. They are molded into the shape of a gutter or channel. They are used in drains. Coping bricks. They can be half round, chamfered, saddleback, angled, varied according to the thickness of the wall. Cow nose bricks. Bricks having double bullnose known as cow nose bricks. Capping bricks. These bricks are used to cap the tops of parapets or freestanding walls. Brick veneers. These bricks are thin and used for cladding. Curved sector bricks. These are curved in shape. They are used in arcs, pavements, etc. Hollow bricks. These bricks are around 1/3 of the weight of the normal bricks. They are also called cellular or cavity bricks. Their thickness is from 20 to 25 mm. These bricks pave the way to quicker construction as they can be laid quickly compared to the normal bricks. They are used in partitioning. Paving bricks. These bricks contain a good amount of iron. Iron vitrifies bricks at low temperature. They are used in garden park floors, pavements. These bricks withstand the abrasive action of traffic, thus making the floor less slippery. Perforated bricks. These bricks contain cylindrical holes. They are very light in weight. Their preparation method is also easy. They consume less clay than the other bricks. They can be of different shapes like round, square, rectangular. They are used in the construction of the panels for lightweight structures and multi-storied frame structures. Purpose-made bricks. For specific purposes, these bricks are made. Splay and cant bricks are made for doors and window jambs. Engineering bricks are made for civil engineering constructions such as sewers, manholes, retaining walls. Fire bricks are made for chimneys and fireworks. Ornamental bricks are made to use for cornices, corbels. Arch bricks are used in arcs. Classification of bricks based on region. On the basis of the region, bricks are of following kinds. Cream City bricks. These bricks are from Milwaukee, Wisconsin. London stock. These bricks are used in London. Dutch. These are from the Netherlands. Nanak Shahi bricks. These are from India. Roman. These are used in Roman constructions. Staffordshire blue brick. These are from England. Qualities of good bricks. The good bricks which are to be used for the construction of important structures should possess the following qualities. The bricks should be table-mounted, well burnt in kilns, copper-colored, free from cracks and with sharp and square edges. The color should be uniform and bright. The bricks should be uniform in shape and should be of standard size. The bricks should give a clear metallic ringing sound when struck with each other. The bricks when broken or fractured should show a bright homogeneous and uniform compact structure free from voids. The bricks shouldn't absorb water more than 20% by weight for first-class bricks and 22% by weight for second-class bricks, when soaked in cold water for a period of 24 hours. The bricks should be sufficiently hard. No impression should be left on brick surface when it is scratched with fingernail. The bricks should not break into pieces when dropped flat on hard ground from a height of about 1 meter. The bricks should have low thermal conductivity and they should be soundproof. The bricks, when soaked in water for 24 hours, should not show deposits of white salts when allowed to dry in shade. No brick should have the crushing strength below 5.5 N/mm2. Strength of bricks. Following factors affect the strength of bricks. Composition: brick making material, preparation of clay and blending of ingredients, nature of molding adopted, care taken in drying and stacking of raw or green bricks. Type of kiln used including type of fuel and its feeding. Burning and cooling processes. Care taken in unloading. It is thus obvious that not only the bricks of different brick fields will have different strengths, but in the same brick field, the bricks of the same batch may have different strengths. The average crushing strength and tensile strength of hand-molded bricks are 60,000 kN/m2 and 2,000 kN/m2 respectively. The shearing strength of bricks is about 1/10 of the crushing strength. In practice, however, the bricks are not subjected to the tensile stresses. It may be noted that the strength of brickwork mainly depends on the type of mortar used and not so much on the individual strength of the bricks. Thanks for watching. For now, please subscribe, like, share and do not forget to press bell icon.